Designing and scoping the menu bar. To write any piece of code, you have to answer 3 questions. Where do I start? Where do I end? And where am I now? But in order to design and architect something, you have 2 different questions. What are all the moving parts? What do I need to know to make them move? Thus, what are the moving parts? Well, I need to know what the menu items are called, and they will show a menu, so I need to link the menu data somehow. 2 options: index into a table, direct pointer. Given I'm only going to have one menu and there are no duplications, adding an index to the table would just cost me bytes and code bytes. But then a pointer to data is inconvenient, and index allows me to unpack a lot of data conveniently. But then since I only have one, the active item number doubles up as the menu data index number. That is all the parts covered. What do I need to make them move? So I need to know which one is selected, but that is an active code data, not a source data problem. So we'll put that under variables. In order to know which one I can select up to, I need to know how many there are. Again, 2 methods. I can calculate the number of items in the menu, or I could store a byte with a number. With such a low number, storing will use less bytes than the count code. On RAM-constrained machines, where you have ROM, storing would be the only real choice. But if I had a lot of menus or dynamic menus, then calculating would be the way to go. So I have my items, I know how many items there are for my next and previous, I know what menu to show when they're active, but where do I show it? Now you could say where is the menu bar's problem, or the submenus problem. If you have multiple menus that share submenus, potentially in different places, you would say it's a menu bar problem. But if a submenu only shows in one spot, then you could say it's a submenus problem. For me, it's a submenus problem. But in order to know where to position them, I will need data from the menu. But this is an assembler data, not code data. And I need a window definition for it. But that is just the whole top row. No need to do anything fancy. I have all the data I need, but how do I want to store it? If I was doing this traditionally, I would have a pointer to strings, then I would draw bar, check to see if this is highlighted. If so, set the change. Draw a string. Turn off highlight. Loop number of items. And then draw the final bar. And if this was ROM bound, then this is how it would be done. I want to highlight another trap or missed trick that I see a lot of beginner programmers fall into. And that is looking for, or rather panicking about, and trying to avoid the don't care or doesn't matter cases. Notice I always turn off highlight. People get caught up in the, well, I should only turn it off because it was turned on mentality. But if it is off and I turn it off, Does it matter? No. Adding a branch to detect that it is on, and then only if on turn it off, wastes bytes and is slower. It doesn't matter if it is off and I set it off again. It's cleaner. But this is not the way I'm going to do it. I'm going to abuse the nature of the kernel and revel in the fact I have RAM. Now a bit about the Commodore kernels. I know I said I wouldn't really explain how this works, but to make this point, I will have to talk about it in this particular case. The kernel print string function takes what is called PESCI, which is similar to ASCII, but it has different symbols and control codes that only Commodore machines have. The kernel translates these PESCI or char codes into screen codes or control codes. Basically, everything in the screen editor exists as a PESCI code. The standard font in Commodore 8-bits has the upper half, i.e. top 128 entries, as reversed versions of the lower 128 entries. And this is how I display the chosen one. Now, it's worth noting that the VDC will also do this in hardware. I could have also changed the color, made it flash, or any combination. By encoding these as codes, I can just make the whole menu a single string. Shift minus is the vertical bar, then reverse off, string, reverse off, vertical bar, reserve off, etc. Now I need to know the index into the string that holds the leading reverse off code. So now when I want to select one, I can set it to reverse on code. Then I just draw the string. When I move, I set the old ones to reserve off, and I set the new one and just draw the string. The lesson here, if you're on a RAM system, don't be afraid to modify the data. As long as you don't destroy the data, you are free to modify it in place. Modern computers and languages put up a wall. This is state, this is data, and you don't ever modify the data portion. But in 6502, data and state are one and the same. So ask yourself, can I store this state into data safely, and if it is easier or cleaner to do? After this, I will go into automation of the string for those that are interested, but I feel this lesson has had 3 points so far, and that is enough for you to dwell on. Next time, I will look at the data and design for the submenu. Automation. The goal is to get a single string with all the decoration and control codes I need, as well as a set of indices to the leading reverse control. We make a list of the strings. Then we loop through it while adding the vertical bar and reverse off first, then append the string, then reserve off. I keep a length of each string plus 3 to accommodate for the bar and revs. Then I take a rolling sum of them to get the offset. Only I started at 2 for the first, so now I append the next offset. Then I add the final bar, output the final string, add the 0. Note that 64TAS does have a .null, which will add the 0 for you. Very handy so you don't forget and print a screen of garbage. But for clarity, I've gone with .0, and then I output the revspos offsets, and then the number, which I slice to remove the last entry for the non-existent next item.